Have you ever gazed up at the sun and wondered how it can keep shining so brightly, day after day? What if I told you that the sun is actually losing a whopping 4 million tons of its mass every second? Crazy, right? But how does that even happen, and what does it mean for us here on Earth and the entire universe? Let's dive in and find out. First, let's talk about what the sun is made of. The sun is essentially a massive sphere of superhot gas, mostly hydrogen, with a bit of helium and other elements mixed in. But here's the interesting part. Deep inside the sun's core, a remarkable process called nuclear fusion is constantly taking place, and this is the key to everything happening inside the sun. At the sun's core, conditions are extreme. Temperatures reach around 15 million degrees Celsius, and the pressure is unimaginably intense. Under these conditions, hydrogen atoms, which are the most abundant elements in the universe, are moving so fast and are so tightly packed together that they can overcome the natural repulsion between them. When they collide, they fuse together to form helium. Now, nuclear fusion might sound complicated, but it's actually a natural process where smaller atoms, like hydrogen, are squished together under extreme pressure and temperature to form a larger atom, like helium. Imagine you have two small Lego blocks. You press them together really hard, and they snap into place, forming a bigger block. That's a bit like what's happening inside the sun, except instead of Lego blocks, we're talking about atoms, and instead of your hands, we have immense pressure and temperatures doing the job. When hydrogen nuclei fuse, something extraordinary happens. They release energy. But not just any energy, this is an energy so powerful that it fuels the entire sun. This energy is released because of a slight difference in mass between the original hydrogen atoms and the newly formed helium atom. Here's where Einstein's famous equation, E=mc², comes into play. It tells us that mass can be converted into energy, with the speed of light squared acting as the conversion factor. Because the speed of light is such a large number, even a tiny amount of mass can be converted into a huge amount of energy. So, every second, the sun is turning about 600 million tons of hydrogen into 596 million tons of helium. The missing 4 million tons? That's being transformed into energy. This energy is what we see and feel as sunlight and heat, traveling across the vast space to reach us here on Earth. In the sun, this fusion process happens millions of times every second. Hydrogen atoms fuse to form helium, and in doing so, they release energy in the form of photons, particles of light. These photons take thousands of years to make their way from the sun's core to its surface, but once they escape, they travel to Earth in just about 8 minutes, bringing us warmth and sunlight. The energy produced by fusion is what powers the sun, and it's incredibly efficient. To give you a sense of just how much energy this is, the sun produces enough energy every second to satisfy all of Earth's energy needs for hundreds of thousands of years. This energy not only warms our planet, but it also drives photosynthesis in plants, powers weather systems, and supports the entire food chain. But here's the cool part. Even though the sun loses 4 million tons of mass every second, it's so massive, about 333,000 times the mass of Earth, that it can keep doing this for billions of years. In fact, the sun has been shining for about 4.6 billion years already, and it still has enough fuel to keep going for another 5 billion years or so. But nuclear fusion isn't just important for the sun, it's a fundamental process that shapes the entire universe. Stars, like our sun, are essentially giant fusion reactors, and they've been transforming hydrogen into helium and other heavier elements for billions of years. As stars age and exhaust their hydrogen fuel, they start fusing helium into even heavier elements like carbon, oxygen, and eventually iron, depending on the star size. This process of fusion inside stars is how almost all the elements in the universe are created. So the carbon in your body, the oxygen you breathe, the iron in your blood, these were all forged in the heart of a star through fusion. When massive stars reach the end of their lives, they can explode in spectacular events called supernovae. These explosions scatter the elements created by fusion across the galaxy, seeding new star systems and planets, and essentially recycling material for future generations of stars and planets. The changes brought about by fusion are profound. Over time, as stars undergo fusion and eventually die, they contribute to the cosmic cycle of birth, life, and death in the universe. This ongoing process drives the evolution of galaxies and enriches the interstellar medium with the elements necessary for the formation of new stars and planets and ultimately, for life itself. Without fusion, the universe would be a very different place. There would be no sunlight, no warmth, and none of the elements that make up our world and our bodies. Fusion is, quite literally, the process that powers the universe. So the next time you step outside and feel the warmth of the sun on your face, remember this incredible journey of light and energy that began in the sun's core through the process of nuclear fusion. This isn't just what makes the sun shine, it's what makes life on Earth possible and shapes the very fabric of the universe. Thanks for joining me on this deep dive into the heart of stars. If you found this journey fascinating, don't forget to like, subscribe, and hit the bell icon for more cosmic explorations. Until next time, keep looking up and marveling at the wonders of the universe.